Well, thank you, Julia, and thank you, Max. You didn't steal too much of my thunder, but that's okay. So I do want to talk about the Cal Strategic Plan a little bit, but just one slide and how it fits into what we're doing here. So basically, good morning, everyone, and this is really gratifying. As you know, there's a lot of familiar faces in here. We get together every year anyway, or even on a daily basis with some of you as we move through some of the trials and tribulations of working with geospatial data. But my role here today is essentially to set the stage for what we want to accomplish today, and so I have a few slides on that in terms of background, where we've been, some of the foundational work that's been done here, and then some ideas on, at least my perspective, on some of the application areas that we need to be thinking about in this next generation that Max was referring to. So the forum is a new idea for us. It's a lot more structured than what we've done in the past. As you know, a lot of you participated in GIS Day previously and have done lightning talks, and we have more of those today, and we'll get more specific as we talk about some of these application areas. So let me proceed here. Basically what I see as part of the planning team, the goals for this forum is basically to constructively engage the geospatial practitioners to address these key issues, and I'll define some of these key issues, and Max has touched on some of them. Provide annual updates, and we do hope to make this an annual forum as we go forward. Across multiple disciplines, and the disciplines are increasing rapidly every day as we get more and more input from people and questions about how we engage with this geospatial technology. Identify those gaps that are lacking in some programs that maybe have the interest and the need to start using more geospatial data but don't have the resources. And again, as always, to define mechanisms to advance scholarship, pedagogy, extension, and service, which is a large component, which sometimes gets overlooked in terms of helping individuals in their particular projects. So the motivation from this, in addition to the work that David and Julia and Saurabh and others have done with what we'll hear about in the next keynote with respect to the Nutrifone and the Atkinson Center. My interest basically in moving this forward are expressed here in terms of we are getting this increased interest and activity among diverse academic units on campus, and it's a really challenge on a day-to-day basis to meet those needs. There's some senior faculty transitions, which means a few of us are going to be retiring very soon, and we're going to have a large gap in some faculty resources on campus, and we need to be thinking about that now and planning for it. The administration also has their priorities and constraints that just because we say we're going to need more geospatial faculty and support staff and student support for graduate students, that doesn't always mean that the resources are going to be there. So hopefully throughout the day today, we're going to demonstrate to ourselves and to the administration and to document those needs so that we can maybe have a little bit more influence with decisions that are made in these different administrative units on campus. And then again, we always want to build capacity. Service learning with students is a new thing, give them more practical hands-on experience with the technology and in workforce development. So these are the four threads. We have a set of questions, and we're going to break out into these discussion groups later this afternoon to get your input, because these two keynotes and the panels are pretty much you passive listening, but we do want to get some interaction from all of you because we are all in the game here. We're all practitioners in the use of geospatial data. But the four common threads that I think that are important that I want you to think about throughout the day are here. One is the faculty leadership that Max had mentioned. Again, we require this faculty leadership to strengthen and sustain geospatial science and technology at Cornell. Pedagogical approaches are changing rapidly. Many of you have heard probably about flipping classrooms and doing different things, but we've taught geospatial science and technology in a very fixed way, established way, and so we have Diana Sinton and others who will be talking about that during our lunch break, about different modes of how we convey this information to different audience types. Besides faculty and what we do in the classroom, there's also institutional support, programmatic support, and infrastructure. Our computer labs are, with this big data issue with respect to the college strategic plan, we're getting Some of the computers that we're using are inadequate to process some of the big data sets that we have to work with, and that we want to train students how to process them as they leave this institution. So we need to always be thinking in the back of our mind, how do we provide that infrastructure? And then there's new analytical tools, areas of inquiry and application that we have to keep up on, and that's partly due to the faculty leaders that we hire, as well as these approaches that we have in the classroom. Okay, just a couple slides on definition. We use this term quite a bit. In the past, we had GIS Day, which was Geographic Information Systems, and we were pretty much focused on one or two different types of software programs that people were using, and we wanted to know what new and creative ways they were using these programs. But it's really broader than that. It's developing into its own field of study and those enabling technologies that allow us to advance geospatial science. Basically about the acquisition, processing, and analysis of geospatial data for meeting the information needs of society. And that's a very general definition, but I think it applies to almost everyone in this room from multiple colleges, multiple disciplines that are using these types of data. Again, geospatial data, again, there's some words here. There's actually a Geospatial Data Act of 2014 that's trying to move through Congress to reauthorize funding of a lot of federal agencies that work with spatial data and produce it for a lot of us who work in those areas. And so some of these definitions are from that legal document, at least a discussion document in Congress. Basically, we're just talking about different types of values that represent facts or measured observations, but what's key here is referenced to the Earth's surface, and some of you folks in here actually do planetary work, but anyway, it's reference to the surface of a planet, let's say, using a well-defined coordinate system, and that's where we end up with a lot of trouble. Sometimes I spend most of my effort helping people resolve issues with coordinate systems because they can't get their data sets to be in the same place on the same piece of the landscape, and therefore make those data suitable for spatially explicit inquiry, mapping, and modeling. So we have a number of things here that you can read by now. That's either represented as a point, as a line, or a polygon, or some other complex feature. The data can be derived from many ways, from actually field measurements, referencing them with a GPS unit, or some form of remote sensing, mapping, or other surveying technologies. And it can include both vector and raster data sets, aerial photographs, and other forms of data. So so everybody, I think, is on the same page. We're all practitioners. I'm preaching to the choir somewhat here, but at least we can see set some boundary conditions on what we want to talk about, and you'll hear more specifics as we go through the day with different panels and lightning talks. Max mentioned the strategic plan, and I'm going to make the same point that he made. Everyone says, well, this is wonderful for all of us in the geospatial community here at Cornell because CALS, and maybe the other colleges have as well, have defined big data as something important. We've all been working with big data most of our careers. It's nothing new to us, but it's coming up into the forefront in terms of strategic planning of different administrative units. But I'll make the same point Max made, is that I think we can look in every one of these thematic areas of the strategic plan and see some role for geospatial science and technology to help advance those particular areas. So that's encouraging, and I've taken some liberty with the terminology here. The Cal strategic plan is published on the web and has a lot more verbiage that goes along with each of these areas, but at least they're, in terms of how we're going to address them in geospatial world, that's what they are. Okay, I'll get to some, what I feel are some important applications, foci, in a moment, but let me struggle with this for at least a minute or two. It's published, one thing I failed to mention, and in the motivation slide, is that at the bottom, this footnote, and this document is available to you on the forum website, at Max's request, last August of 2013, he pulled together a number of faculty chairs and myself to be able to help define what the needs are for the college and with respect to geospatial science and technology. So we wrote this briefing paper for Dean Bohr, and it's called Sustaining Geospatial Science and Technology at Cornell. So it's there. It's been edited a few times by the planning committee. The version that's up there now is probably August of 2014. But please take a look at that and use that as a basis for providing input to us during today and after today in terms of how we want to define how we move forward and sustain this program at Cornell. So part of that document is our first attempt at an inventory of where we are teaching a lot of this in different courses, and I know that's difficult to see. Don't worry about it. The main thing is that we have a number of geospatial topics, and these are ones that a few of us had just listed, and there's probably others, but I think we can probably all find a place for ourselves in that list. Then we have the number of colleges, the number of units within those colleges, and then I added a line later, which has caused more confusion probably, an RT&E, which are we using it for research, are we using it for teaching, are we using it for extension and service? And then the main matrix is just this code down here, which says whether that particular unit is offering that particular topic in any sort of a course. So it's fairly limited to the teaching program. And again, it's out, as soon as you put something like this together, it's out of date. Most inventories are, so you got to be diligent about updating this. And so what we'll do, perhaps, is use this as a mechanism or a tool to be able to move forward and update this so that not only CAL's administration, but also the other colleges who are contributing and allocating resources to advance this will see where some of the gaps are and where we're not teaching and where we need to do that in the future. So anyway, keep this in mind, and if you want to refer to it during the day, it is on the forum website. Okay, very briefly, I did talk about history. We go back quite a ways, even though some of you may not believe it, but we can go back probably in the late 19th century, and there's a lot of geologists, earth scientists, and soil survey started in the United States, and we were not using any form of remotely sensed data at the time except our eyes and our observations in the field, but we were using plane tables and alidades to make maps and map soil properties spatially on the landscape, and some of those maps still exist. In 1918, if you read This Week at Cornell History on the Cornell Chronicle, there was a nice one in February, and I'll show it here in a minute, that there was a School of Aerial Photography in the College of Engineering, and it trained Army pilots to take aerial photographs, and those aerial photographs exist in an archive, some in the National Archive and some in Pittsburgh, I believe, but we haven't done that investigation. The middle of the 20th century, again in engineering, civil and environmental engineering, there was the Center for Aerial Photographic Studies, did a lot of work, world-renowned work in surveying, photogrammetry, remote sensing, site evaluation. And probably in the last half of the 20th century, the Resource Information Lab in CALS was created to do more land use, land cover mapping, primarily using aerial photographs of different vintages. In 1984, Dean Dave Call said, well, why do we have a unit in engineering and a unit in CALS that do geospatial stuff, even though he didn't use those terms back in 1984. And he combined the Center for Aerial Photographic Studies and the Resource Information Lab and formed CLEARS, the Cornell Lab for Environmental Applications of Remote Sensing. And we were based in the Center for Environmental Research at the time, which morphed into the Center for the Environment, and is now, I guess, the Atkinson Center, even though that lineage is checkered, not checkered, but at least a dashed line. And in 1984, we had the first annual New York State GIS conference. So this is our 30th anniversary of not only Cornell, but also the state of New York having organized meetings about what we do in the area of GIS. And so it's now, we now have a New York State GIS Association, in which a number of us participate in, as well as some other organizational entities. So I come into the picture in 1986 because CLEARS and now morphed to IRIS. But CLEARS has three programs: remote sensing, directed at the time by Professor Bill Philpott in civil engineering, who's here, now directed by Magdalene Laba. The resource inventory program that was directed by Jeannie Barnaba, who many of you know, now directed by Susan Hoskins. And then I was hired as a professor of agronomy in 1986 to head up the GIS program, which I did for about 10 years. And then things evolved, and now Steve Smith is the GIS program leader for IRIS. Also in 1989, we were able to, because CLEARS was formed, we had this movement going that we convinced the dean to hire a lecturer to start teaching geospatial science and technology, or at least GIS, and that was Roger Slothauer. Many of you in the audience have worked with Roger for many years. He's passed, unfortunately, but Roger was here from '89 and taught the 2 GIS courses in natural resources until 1985. Those courses were transferred to CSS, and then I started teaching them. And then about 1990, about the 90s, a lot of other units started to mobilize and have interest in their faculty and their staff and their students to be able to do GIS stuff. And now we're at the present where, again, we're at this meeting with 135 people here that are extremely interested in how we move geospatial science and technology forward. So it's been a great evolution, but it's nothing new in terms of what Cornell has been doing. We just use a different form of imagery or a different form of data to be able to map things spatially on the Earth's surface and then make some important resource management decisions with those, or planning decisions. Okay, let me go through a few highlights in terms of application areas, a couple of more history slides here. About that time in the early 20th century and late 19th century, again, it was all field-based. But this was the paradigm, This was the paradigm, This was the paradigm that we used, at least in the agricultural sciences, in terms of how we manage resources and produce crops on the landscape. But again, still maps were made of soil properties to be able, and landscape different properties using, again, plane table and LOD to be able to do that. Then we were able to get aerial photographs, and one of my nicest examples of an analog GIS, because we're not talking about stuff that's all computer-based. With the photos, aerial photos that were acquired in the 30s based on the Roosevelt administration, the Agricultural Adjustment Act, most of the agricultural areas in the country were photographed in the late 30s. And so there was a hurricane in the area, and so in Schuyler County, there's the physical land conditions of Schuyler County circa about 1942, but they used the 1938 aerial photographs to be able to map all the resources and erosion conditions, and actually to make plans of how to take a lot of agricultural land out of production and put it into either continuous cover crops or plantation forests. And so again, it's an excellent example of GIS, but again, it's all done by hand mapping and not, but still some remote sensing was used as the original input. This is that example. Again, if you can see this for yourself, this was that where I first learned about the aerial photographs being taken in 1918 by the Army air pilots that were being trained in the College of Engineering. And this is a picture, they said, of the southern end of CUGEO Lake, but because a lot of us are experts in aerial photo interpretation, this is not the southern end of CUGEO Lake. It's actually the southern end of Owasco Lake. But be that as it may, again, we do. Okay, okay, I'm going to go through about 3 or 4 slides, and I'll conclude. And some of the application areas. So again, we were talking about faculty expertise. We're talking about pedagogical approaches in the classroom, how we do that best in terms of conveying sort of the first principles of geospatial science and technology. What's the infrastructure we need to do that? And then thirdly, what do we have to start planning for, or either contemporary or in the future perspective views in terms of the application areas, and where do we need this faculty expertise, graduate students, senior staff to be able to move this forward? So this is one, I started in this world probably around in the early 70s with aerial photographs and the first what were Landsat satellite images to make resource inventories, and I was out in the West doing it in agricultural lands as well as rangelands, semi-arid and arid rangelands of the West. And again, you can see here, this is the same area. It happens to be an area in Western Kenya, but it could be anywhere. We can see the increase in spectral and spatial, well, right now it's all constant in terms of its spectral resolution, but in terms of spatial resolution, with these pixels being about 60 meters in terms of ground sample distance, multispectral, and then going through the 80s, the 2000s, Rapid Eye with about 5-meter data, and now Digital Globe, Worldview 3 now, with about, and they just authorized 0.3 meter ground sample distance. So the imagery that we're acquiring for the Earth's surface is just incredible, and it requires a lot of new computational ways to be able to analyze that in a more efficient way. So I think we need to continue faculty resources in the area of digital image processing, and for again 40 or 50 longer years it's been in civil and environmental engineering, and we teach an applied class, but in Bill Philpott's course it's more on the fundamentals, and Bruce in earth and atmospheric sciences also uses this in ocean systems. So again, I don't want to see that lost, and that's why we've broadened our discussion from GIS. Everybody's talking about GIS, what we do with the data that's already been collected and analyzed from a remote sensor, a sensor. Let's also pay attention to the remote sensing end of things. And that gets us to the next one, which is a derivative of a lot of these spectral data from different satellites, is NDVI, or the Vegetation Index. And I'm not going to go through this other than to say that we've got satellites that are providing data, can either be at a relatively broad spectral band to be able to compute a vegetation index, and a lot of you have used it, so I'm not going to go through the basics, but there's some references in the back of my talk if you want to go through this. And also the enhanced vegetation index, which actually uses the blue band to be able to augment some of the measurements that we're making, except that they're produced at different resolutions, at least on this particular satellite. But in the future, we're going to be getting satellites of higher resolution as the rapid eye with these, or with a digital globe, but with these multiple narrower spectral bands in terms of hyperspectral imagery with narrower spectral bands throughout this particular spectrum, at least in the visible, near infrared, and shortwave infrared. And some of you are working in the thermal region as well, but I don't have a slide for that. So again, the remote sensing part is a key element to keep in mind as we move forward with determining the next generation of faculty expertise. One that's has just a satellite that's just been launched as a soil scientist, agronomist, if you will, is SMAP, which is Soil Moisture Active Passive. That's kind of a weird acronym, but NASA always comes up with kind of weird acronyms. But it's a passive sensor. It's an L-band radiometer in the radar region, and an active sensor, an L-band radar sensor that was launched last February. They're still going through some testing on this, but hopefully in the future the goal is to be able to create global maps of soil moisture every 2 to 3 days. So it's an incredible sensor, which I hope gets online and starts producing data. But again, we don't know the best way to analyze this or how to use it in some of our other process-based models for looking at agricultural systems or farming systems around the world. I'd be remiss, this is another area we need strengthening at Cornell, especially in my department, or now section in the School of Integrative Plant Science, is in precision agriculture. And so we have a couple lightning talks that are going to talk about some specific applications of geospatial technology with respect to precision ag. And this happens to be just one image of a normalized difference vegetation index for a field here. There's other sensors on this set of instruments here. So again, there's a number of people in the audience who are going to be talking about this. Professor Gore's program in plant breeding is using a lot of both remote sensing, proximal sensing, we would call it, pretty close to the ground for looking at plant phenotyping. So we've got a lightning talk on that. So hopefully some of the things that I'm showing you here will be expressed in a little bit more detail during those quick lightning talks early this afternoon. Another area that we need to be prepared for acquiring geospatial data are, we don't call them drones. If we call them drones, we're at a higher level and with the military, but they're called UASs, unmanned aerial systems, and sometimes people call them UASs, which are small unmanned aerial systems, and as opposed to the larger ones that fly around. But they're either in fixed wing style here with this Trimble unit, or the Regal quadcopter here with a new LiDAR sensor that weighs about 2 kilograms. Being able to take, this is probably a lousy image of a LiDAR image, but at least it allows us to get a point cloud where every point in that point cloud is georeferenced in 3 dimensions, and also is able to classify it into its different components. These things acquire data probably at about 500 kilohertz. So we're getting data points, a point cloud, about 500,000 points every second. So that's big data. And so how you process those data is really important, and we need the computational tools to integrate more with the folks in computer science, computer information science, as well as those in the applied sciences to be able to analyze these data properly. And lastly, we have digital soil mapping. This is again an area where faculty expertise is required. This is sort of a shifting paradigm from back when I was talking about the late 19th century. The soil survey program was started about 1890, 1895, in the 1890s time frame. But you mapped soil properties, you integrated those soil properties, and you call the soil a name, a different soil series. Well, now the whole paradigm is to actually map soil properties, and that whole idea of creating a traditional soil survey is somewhat out of date, I guess. I'm not going to call it anachronistic, but at least it's we're mapping properties, and they're using a lot of inferencing systems to be able to do this, where we have existing legacy soil data, expertise, different sorts of environmental covariates, we call them, to be able to predict based on the soil forming factors those properties. So there's a lot of statistical, mathematical modeling that goes on over here, and so we're going to need that expertise in new faculty and new graduate students and staff to be able to take these environmental covariates and do prediction models of different soil properties. And so we, again, keep that in mind as we go through the day. And the latest thing on the streets is Soil Grids 1 Kilometer. It's a new soil grid map of the entire world, created by folks at these gentlemen here and these individuals, creating soil data at a 1 kilometer scale of about 6 or 7 different soil properties. And we're getting, this is the current product, the Harmonized World Soil Database, which is relatively coarse, about coarser than a 1 kilometer raster or pixel, if you will. And so you can see this area for northern Italy, the level of resolution is increasing. So again, bigger and bigger data. So big data is just something that's fairly common in our world, as you know. So that's sort of some of the highlights in terms of the application areas. I think I need to conclude now so we can give time to Professor Erickson. But what I wanted to end my talk on was where we go from here, at least today in the short term. You've heard enough about where we need to go in the long term in terms of faculty expertise and infrastructure support, pedagogical approaches, and the like. What I want to do is to encourage all of you to participate and to give us your views through these these working group discussions. And that's going to occur for about an hour this afternoon, because we have the panels this morning. We have the lightning talks early afternoon. Then we have about an hour after afternoon break to go into these 4 different groups on those common threads that I defined. And then to come up with some very specific things. We want to compile your input in a participatory way so that we can formulate this game plan, or at least our next version of our briefing paper, at least to Dean Bohr and College of Agriculture and Life Sciences, but also other college administrative units are going to find this of interest, I hope, because they're getting the same demands from their faculty and students and staff to address these issues with respect to geospatial science. So we've broken out the discussion groups along those 4 threads, the one being related to faculty expertise and getting input from all of you in a formal way in terms of what you think are going to be required in terms of who's going to replace me, or who's going to replace Joe Francis, or who's going to replace others as they fade away, or I don't know how to put that. I thought, you know, old professors don't die, we just get more transparent. I don't know. I guess that's better than being opaque. But anyway, so we'll have a breakout group on faculty, a breakout group on these pedagogical approaches. So some of you who are in the classroom that teach this a lot and need to come up with different ideas. And so Diana Sinton will be leading that group. I'll lead the faculty group. Breakout group 3 is going to formalize some of this programmatic support and infrastructure that we need, and Boris will be moderating that with an assistant. We'll all have assistants to record your input. And the 4th group will be led by Joe Francis on sort of these new emerging application areas, as well as analytical tools and methods that we need to make sure that we've got that infrastructure set and the tools prepared for conveying this information, for teaching the next generation of graduate students, for workforce development, for service learning ideas for students and other things. So with that, and then at the end, we posted these, Keith has posted these on the website. I'm not sure they're there, but there's a set of references that sort of highlight some of the application foci in the history that I talked about. So thank you. Appreciate your attention, and I'll answer a couple questions before we turn it over to David. Thank you.